Alright class, tonight we're going to do 5-3, medians and altitudes of triangles. Our objectives are to apply properties of medians and altitudes of a triangle. A median of a triangle is a segment whose endpoints are a vertex, segment C of the triangle, and the midpoint of the opposite side. So CD is your median. Point D bisects segment AB. Every triangle has three medians, and the medians are concurrent. That point of concurrency is called your centroid of the triangle. The centroid is always inside the triangle, and another name for the centroid is the center of gravity because it is the point where a triangular region will balance. So we have our centroid theorem here, and what this is stating is we have median AY. So the endpoint from the vertex to the centroid. So this segment, AP, the measurement is 2/3 of the median AY. Same for here. We have median BZ. So segment BP, from the vertex to the centroid, that segment is 2/3 of that median. So let's apply this. Okay, we have triangle LMN with some measurements. We need to see if S is the centroid. Well, endpoint vertex, opposite side, bisects this segment. Vertex, opposite side, bisects this segment. Vertex, opposite side, bisects this segment. So C is the centroid of that triangle. I'm sorry, that's S, not C. S. So we can apply our centroid theorem. We're trying to find LS. LS from vertex to centroid is 2/3 of that median. So LS equals 2/3 of RL. Substitute in what you know. And then SQ. SQ is given. That's from the centroid to the segment. So that's 1/3 of that median. So SQ equals 1/3 of NQ. SQ is 4. You're trying to find NQ. So to isolate that, we multiply by its reciprocal. And Q equals 12. All right, I'm going to be quiet, and you all do this one on your own, please. All right, let's move on. An altitude of a triangle is a perpendicular segment from a vertex to the line contained in the opposite side. Okay, in the past, you might have heard your math teacher call this the height of the triangle. In geometry, we call it the altitude. Every triangle has three altitudes. An altitude can be inside, outside, or on the triangle. Okay, so we've got triangle QRS, and altitude YQ here is inside. Vertex to opposite side, perpendicular. Okay? Altitude RX and altitude SZ are on the outside of the triangle. Vertex to Z, outside the triangle. Here's where it's perpendicular. Rx, vertex, to x outside the triangle. Okay, the altitudes of the triangle intersect at the point of concurrency. This is called the orthocenter of the triangle, point P right here. All right, so to find the orthocenter, the first step is to graph those points, okay? Step one. Step two is to find, we've got to find this altitude. So from point Z to segment YX is going to be perpendicular. We have a point. If we can find out what the slope is, we can substitute into the point's slope equation to find that equation. So step two is let's think slope. And we're going to go from point Z to segment YX. Okay, so slope of YX. Well, YX is what type of line? Vertical. So you know that your slope is undefined. However, to have a line perpendicular to a vertical line, you have to have a horizontal line. And you all should know that the slope of a horizontal line is 0. Okay, so we have slope of the line that contains point Z and it's perpendicular to YX. So let's go to step 3. Step 3 is we're going to use point Z, which is 7, 1, and we're going to use slope 0 because that's our slope of the line that is perpendicular to YX, and we're going to substitute into our point slope form. Okay, let's clean this up. Right side is going to be 0, y equals 1. So, we have one coordinate of our orthocenter. Now we've got to find the second coordinate. Okay, so we're going to go back to step 2, where we were talking about slope, and let's look at another altitude here. Okay, so what I'm going to do is I'm going to look from point Y to segment XZ. Okay, so I need the slope of XZ so that I can find the slope of the line that is perpendicular to that contains point Y. So remember, slope is your vertical change over your horizontal change. X is 3, negative 2. Z is 7, 1. So we have 1 minus a negative 2. 7 minus 3. And we get 3 over 4. So the line that is perpendicular to XZ is going to have a slope that is opposite reciprocal. Opposite reciprocal. Okay? Now I'm going to erase so we can do step 3. Okay, so we're going to use slope with opposite reciprocal. And we're going to use point Y, which is 3, 6. And let's substitute in. Y minus 6 equals negative 4 thirds. X minus 3. Let's clean this up. Let's isolate our variable Y. Okay, class, so what we have here is we have y equals 1. Let me erase that. This is our last step here. This is step 4. Okay, so we have y equals 1, and we have this equation, y equals -4/3 x plus 10. Okay, we're trying to find our orthocenter here. So, we've got our y coordinate. We need our x coordinate. So can we substitute it for y and find out what x is? Multiply by that reciprocal. So x is going to equal this right here is the orthocenter. All right, guys, that's it. See you tomorrow.